Okay, so just a quick review. So what we're trying to do is we're trying to find the length of the chain to connect these gears, just like the chain of a bicycle. It would be good to know the exact length. That way we can mass produce this chain in a production system if we own the bicycle production company. So we want to find first the part of the chain to the left side of the bigger gear. So that's an arc for the bigger gear. And then we want to find the part of the chain that's the right side of the smaller gear, so the arc of the smaller gear. And then we got the top and bottom parts of the gear that are connecting the left side to the right side. So I labeled those as X. So the formulaic way of what we're doing this, we're finding the arc of BE, and then the X, there's two of them, and then the arc FD. So that's just a formulaic way of what we're doing. And so this is what we're given. The big gear has a radius of 4.5. Small gear has a radius of 2.5. And when we connect the centers of the two gears, the distance is 17.5. Now, the basis of this problem is interpreting the geometry. The reason you have right angles at B and F, and also on the bottom D and E, is because the gear coming off of the circle is tangent. And when you're tangent to the radius, you make a right angle. All right. So that's why those are two right angles. So tangent to the radius, you make a right angle. And as soon as we do that, we have consecutive interior angles that have a sum of 180, which means the left and right lines have to be parallel. Okay, which means this is a trapezoid. Two sides are parallel. And then the two angles on the bottom of the trapezoid are labeled A and B. They have to be 180 when you add them as well, because again, once we know the lines are parallel, the consecutive interior angles are supplementary. So that's how we're establishing those two angles I'm labeling A and B are parallel. Well, the arc on the left side of the bigger gear would be actually 2B because the angle over here is supplementary to A. And there's also one on the bottom. So we're going to use a central angle of 2B for the bigger gear when we find the arc. And same thing over here. For the arc of the smaller gear, the angle is actually A because it's supplementary to B. And then there's the angle on the bottom. So the arc for the smaller gear on the right side, the central angle is 2A. Okay, so now we got to do the math. So just establishing the underlying geometry, and why we can set up the problem this way. Okay, so now what do we do? Well, we got to find X, and then we got to find one of the angles, and then we can find the other by just subtracting from 180. Okay, well, since this is a trapezoid, we can drop a line parallel to the top right here. If we do that, that makes a right triangle. So there is a line parallel to the top that we could draw right here, which gives us a right triangle, and I drew that over here. Well, we already know 17.5 would have to be the hypotenuse of that right triangle, and then the X would be there. And the leg over here on the left side is 2 because that would be the difference between 2.5 and 4.5. Okay, so then we're just solving this Pythagorean theorem to get X. And now we got to get one of the angles. And so in this right triangle, we got the A angle here, and that's adjacent to the 2. So we'll use the cosine, adjacent over hypotenuse. Now we want to find the angle A, so then we do the arc cosine of the ratio. That'll give us the angle A, and then we subtract from 180 to get B. Now, if you're using the degrees, which if you're using radians, then this would be 2 pi minus, or rather pi minus. But again, use degrees. All right. So now that's the math you would do. And then to get the arcs, your central angles over here for the bigger gear would be 2b. Over here for the smaller gear would be 2a. So 2b proportional to the 360 times the circumference, and then 2a proportional to the 360 times the circumference. So again, if you, for whatever reason, are using radians, just make sure you would subtract from pi and divide by 2 pi instead of 360. But I just suggest degrees for whatever reason. Okay, so once you get the x and once you get the angles, then you can find the length of the arcs. And so that's what I'm saying down here formulaically. You got two of those x's, you got the arc on the right side and the arc on the left side. Okay, so just to recap in case that's helpful for anybody.